Alright, good day guys, how are you all doing? Um, we're talking about binomial theorem today, and under binomial theorem, the first important thing that you need to understand in order to, go straight to the point in some cases is understanding Pascal triangle. You get? So, and the other one is using the normal binomial series formula to break to some certain things. Now, what do we call a binomial expression? You see, a binomial expression is like the one that contains two terms. Now, irrespective of how the particular questions are being given, these actually still contain two terms. Are you get what I'm saying? So, example of those kind of two terms are you having x plus y, 2x minus y, and most of those terms, it's not even most of the term, the terms are being connected with either plus or minus. So, this, as you can see now, they are example of what we call a binomial expression. And since we could categorize them in this form, then we have to generate just like you generating a particular sequential end term for it. So in that process, we could say that okay, this could be categorized as saying k as the first term plus q being the second term raised to power a certain number. Now this number could start from 0 till infinity, 0 upward. That's n greater than or equals to 0. So there are three things that we need to understand and take note of before we proceed to what do we call Pascal triangle on its own self. Now you see Pascal triangle is like just application of a shortcut there. Not shortcut also because it also has its own orders. So Pascal triangle is just like a process of applying a straight shortcut, and why the normal series them also really helps too. Now, what are we trying to say is that these three things are very important. The first thing is that you see this power here. When we want to deal with the expansion, either you have been asked to expand, let's assume you have something like k plus q raised to power 6. So this is a certain expansion you can be asked to expand. So at that point now, k will decrease in power as it keeps moving from left to right. That means that let's assume that you have k raised to power 6. As k keeps moving from left to right, you'll be having k raised to power 6, k raised to power 5, k raised to power 4, then like that till it keeps what decreasing momentarily. While q will keep increasing in power. That means that when q starts from 0, q will keep increasing also from 0 to 1 to 3 to 4 to 5 till it gets to what? 6. Are you get what I'm saying? So those two things are very important for us to understand first. The first term here will reduce as it keeps moving. The second term here will increase as it keeps what? As it keeps moving. Now the last one is that the coefficient. What do you call coefficient? I've said this thousands of times that let's assume you have something like 6x. Being having 6s, coefficient is that sign and number. Now it can be fraction, it can be anything. Let's assume I said I have minus 1 over 2x, 7 over 3x. The coefficient is that sign and number beside a certain particular alphabet. That is, if I'm to ask that what is the coefficient of x here, I'll be having what? Minus 6. That's my coefficient. What is the coefficient of x here? Minus 1 over 2. What's the coefficient of x here? 7 over 3. So, are you getting what I'm saying now? So, the last thing I want to talk about is that the coefficient of each term, when you expand them, they are symmetrical about the middle coefficient. Now, what do they mean by symmetrical about the middle coefficient? When n is even. Now, when the certain number is even, like something like this, what do they mean by n is even? When the power, now let's say you have the k plus q like we said. Let's say k plus q raised to power 2, k plus q raised to power 3. This is an even power, this is an odd power, right? So, if it is even, then surely the particular expansion will be symmetrical about the middle value. Now look at what they meant now. You can see 1 and 1 are symmetrical. 4 and 4 are both symmetrical. All of them are symmetrical about what? The middle value. So at that point, we should know that what? The power then with this is associated with what? An even number. But if it is an odd, it will be symmetrical about two middle number and two middle coefficients when n is odd. So the both coefficients will be symmetrical at the same them. Looking at now, 1 and 1 are both symmetrical about another symmetrical coefficient. So that's what they meant by this particular part here. So let's move on to the important aspect of the Pascal triangle itself. And what is it talking about? Now when you hear the word Pascal triangle, when you hear the word Pascal triangle, you should know it refers to a certain triangle. So you can draw a triangle first. This is just like an illustration of what we need to do. Now we are considering testing Pascal triangle. That how does it work for expansion of our depth? And Pascal triangle just help in inserting the values that we need. Now let's assume we said, just like we have said that n is starting from 0 upward. So we want to test n for each certain particular variable. That what will be the like much more like the coefficient value of each function. Now if you start from k plus q equals to 0, k plus q raised to power 0, we should know that anything raised to power 0 will surely give you what? 1. Are you me? So that means the expansion of k plus q raised to power 0 in terms of the numerical value that would be standing at each point. Anyhow you want to do them, all of them will just be tends to a certain constant number, which is what? 1. Are you me? So we look at k plus q raised to power 1. What we are dealing with under Pascal triangle is that we are writing mainly the coefficient of the values down. That's just like an expression that we could symbolize it as. Now move on to the next one. K plus q raised to power 1. Now when you expand k plus q raised to power 1, you should know that will only give you what? K raised to power 1 plus q raised to power 1, right? And what's the coefficient of k? You have 1. You have 1. Which means this will be k plus q, also known as 1 plus 1. Are you get what I'm saying? The next one we have k plus q raised to power 2. Then from there now, we know k plus q raised to power 2, you can expand it. That is having something like this. K plus q into brackets k plus q. Multiplying it, this will give you k squared plus 2kq plus q squared. Each coefficient of the expression, coefficient of 2kq rather, because this will be kq, this will be kq. So you have 2kq. The coefficient of k squared here is 1. Coefficient of kq here is 2. Coefficient of q squared here is what? 1. That means we'll be having what here? 1 plus 2 plus what? 1. Now you get what I'm saying? So at this point, 1 plus 2 plus 1. So at this point now, if you had to take a good look at it, if you had to deal with k plus q raised to power 3, you would see that with all the expression, everything in this side will be 1. Everything in this side will also be what? 1. What we have to start dealing with now is how do you get the other middle values variable? And there's a certain straightforward method in order to get the middle value variables. How do we do that? Is that now if you look at this point now, 1, you have 1 here. It expands to 1 plus 1. Because 1 would stand alone with a certain particular variable of 1. Now we know the next value that will be here will be 1. So 1 plus 1 will give you the middle value of whatever you have here, which will give you what? 2. And since there's nothing more that could add up, we should know the last time will be ending with also what? 1. Now what am I going to put here? You have 1. How you get what I'm saying? 1. Now this will be 1 plus. We know that 1 plus 2 will be the next variable there because 1 plus 1 was all give us 2. There's no other thing to add. Then we know that the last term has surely occurred, which is 1. Now 1 plus 2 will give us what now? 3. Plus, you should know we can still add up now. Since 1 plus 2 added, 2 plus 1 can also still add up. How you get what I'm saying? So 2 plus 1 will give us what now? 3. Are you with me? Then plus what? Plus 1 because there's no other term it can add again. The same thing next time if you have to deal with k plus q raised to power 4. So having k plus q raised to power 4, we start with our 1. You have 1. We should know 1 plus 3 will be what? You having what? Plus 4. Are you get what I'm saying? Then 3 plus what? 3. You have what? Plus 6. Then 3 plus 1. You have what? Plus 4. Then is there anything to add up again? Nothing more. Then plus our last term, which is what? 1. Are you get what I'm saying? So moving on again now, you having k plus q raised to power 5. The same thing is applicable to this. What are you going to be having? Our 1 first. 1 plus 4, you are going to be having plus 5. 4 plus 6, you have plus 10. Are you with me? 4 plus 6, you have plus 10. 6 plus 4, you still have plus 10. Are you get what I'm saying? 6 plus 4, you have plus 10. Then 4 plus 1, you have what? Plus 5. Then our last term, which is what? 1. Are you get what I'm saying? Then like that, and so on. It gives you the coefficient of each certain particular variable. But this plus is just for us to bring out a shortcut of quickly expressing it. Are you with me? So at that point now, we have this. These are the expression. These are the expression. These are the expression. Because at times, So these are the expressions that you have there. You can keep expanding more, but I feel like I should stop at k plus q raised to power 5. So you keep expanding more, you get certain particular variable. These are literally mainly for positive integers upward. Are you with me? This is a symbolism of Pascal triangle, how it is being expanded, how it is being expressed. So if you want to, let's assume you want to solve a certain particular equation. Let's look at solving a certain particular equation with Pascal triangle. Now, at our normal point, like I've said, we are still based on only using Pascal triangle to just ignore any other expression or any other sequential thing. So if you are to expand k plus q raised to power 5 using Pascal triangle now, what you just have to take note is two things. First and foremost, you know that what the coefficients are this. Write your coefficients. You have 1, you have 5, you have 10, you have what do they call it? 10, you have 5, and we have what? 1. Are you getting what I'm saying? Now what do you have to do is, at this point, you should know that the separation, what separates them is what? Plus. Do not forget. So if you have to expand something like this now, like I said, if you could remember from what I talked to you guys, I said as k increases, q decreases. And with what we have just been expressing, that shows that k and q are like human, they are together, they're like product. That is something like this. You have this now. You have 1, k starts from the highest value. You have k raised to power 5, q raised to power what? 0. Ignoring anything, there are expression or formula for this thing, how it is being used. But because we are dealing with Pascal triangle, all our eyes are famished on normal expression, no any formula being called in. Are you with me? So all we know is the relationship between kq and k decrease, q what? Increases. Are you with me? So the next value we have there is what? Plus what? 5. And that will be k becomes 4, q becomes what? 1. Then the next one you have 10. K becomes 3, q becomes what? 2. The next one you have 10, k becomes 2, q becomes 3. Can you see this life? So no matter what you do in this life, just make sure that one day you are also going to move to another certain position in life. Do good. Now from there you have the next one we have 5, right? Plus 5. What will be k becomes 1, q becomes 4. Plus 1, k becomes 0, q becomes 5. Are you with me? So this is like an expression of what we are trying to explain. And at this point now, this will become k raised to power 5, because k raised to power 0 will give you 1. 1 times 1, you have k raised to power 5, plus 5k raised to power 4, q raised to power 1, or you see ordinary q. The next one we have plus 10k raised to power 3, q raised to power 2, plus 10k raised to power 2, q raised to power 3, then plus 5k q raised to power 4, and the last one plus what? Q raised to power 5. So you can see the application of Pascal triangle in order to break things down quickly and efficiently. So this is the utilization of Pascal triangle in order to make things much more easier. Are you getting what I'm saying? Let's move on to its main law or its main rules.